Okay, so today we're starting law of sines and cosines without it telling you explicitly which one it is that we're doing. Okay, so at this point you've got to be able to figure out, am I doing a law of sines or am I doing a law of cosines problem? Okay, now the easiest way of doing that is this way that I've been telling you to set it up, with angle A inside A and angle B inside B and angle C inside C set up this way, will show you basically if you are doing a law of sines or law of cosines. They are set up this way because they are explicitly showing you the ratio of sine A over A and sine B over B and sine C over C. Okay, so if you have one of these rows, then you have basically a law of sines problem going on. So if you can get one ratio, you can do law of sines. If you don't have one of these, you know it's a law of cosines problem. Okay, so we're going to write in our information. So we know angle B is 27 degrees. We know side B is 31 and side C is 24. Okay, so seeing that I have both angle B and side B, I can use law of sines. Here's the other thing that you got to check. Is this the ambiguous case? Do I have two sides and the angle that goes with one of those sides? Well, yes, I do. Looking at it right now, I have the ambiguous case. So now I got to decide, do I have any solutions? Do I have one solution? Do I have two solutions? Okay, so the first thing I need to do is I need to find my height. Now, since they gave me angle B, side B, and side C, my height for this one is going to be C times the sine of angle B. And that means it's 24 times the sine of 27. And we plug that in your calculator, you get 10.895, blah, blah, blah. And obviously 31 is way bigger than that, so I have at least a solution. Then we look, is this side bigger than the other side? Yep, and since it's greater than the other one, automatically we have only one solution. So it is a law of sines ambiguous case, but only one solution. Okay, so it means I go straight into law of sines. So we start with our given ratio. So sine of 27 over 31 equals, the next piece of information I can go and find is angle C. So I set up my law of sines. That means angle C is equal to the inverse sine, and this is 24 times the sine of 27 over 31. And because we're looking for an angle, we're using our inverse trig function, so C is approximately 20.577652, yada, yada, yada. So I always tell my students to round to the 10th, so this should be 20.6 degrees. Now that I have two angles, since I know they all add up to 180 degrees, we can find A by subtracting it, and you get angle A for B 132.4 degrees. Now that I have angle A, I can find side A by doing law of sines again. So law of sine 27 over 31 using the same ratio. And now using the angle from A to find side A, that means A is equal to 31 times the sine of 132.4 over the sine of 27, which means it's approximately 50.424217, blah, blah, blah. So this is 50.4. And now before we move on, make sure that my measurements make sense. So the smallest angle should have the smallest side with it. Biggest angle, biggest side. So it looks like my answers make sense. Okay? All right. Second problem. Okay, we're going to start off the same way. Again, putting it into this chart is going to help me decide, am I doing law of sines or am I doing law of cosines? So put in angle B, 113. Then side A is 14 and side C is 22. Okay? And as you can see, I have no ratio that I can use to do law of sines. I don't have at least one angle with its opposite side. So this is telling me that I'm doing law of cosines. Not only that this is the side angle side case, which means the only piece of information I can solve for right off the bat is side B. So we use our law of cosines equation, this one, b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Okay? Which means b is going to be equal to the square root of all of this, and it's 14 squared plus 22 squared minus 2 times 14 times 22 times the cosine of the angle, which is 113 degrees. And you plug all that into your handy dandy calculator, and it says that b is equal to 30.34288, yada yada yada. So side B is 30.3. Now, normally if I'm doing law of cosines and I'm switching to law of sines, I'd have to be careful because when I go to find one of my other angles, if it's an obtuse angle and I'm using law of sines, it won't give me the right angle. But since B is already an obtuse angle, I don't have to worry about that because there can't be two obtuse angles in a triangle. So it doesn't matter what you solve for next. I solved for A next just because it's the next one in the alphabet, or the first one in the alphabet. So set up your law of sines. So I have this ratio now for B, and I'm going to use it to find angle A. So since I'm looking for the angle, I know I'm using the inverse trig function. So inverse sine or arc sine, cross multiply. So it's 14 times the sine of 113 over 30.3, which means A is approximately 24.132608, yada yada yada. And again, round to the 10th place. So angle A is 24.1 degrees. And now since I have two of my angles, I can subtract them from 180, get my third angle, which should be 42.9 degrees. And again, double check your answers. Okay? So angle B is the biggest angle, has the biggest side. Angle A has the smallest angle with the smallest side, and then angle C is right in the middle, in between the two. So it's not an absolute way of making sure that you're correct, but it definitely keeps you from making any glaring mistakes.